OK, oh, now I'm echoing myself. Yeah, I'm a content creator. I have a YouTube channel where I post a lot of videos on serverless and these things. And also, I have many online courses. So I enjoy teaching and sharing my knowledge with you. And before AWS, I was working in the company that makes Angry Birds. And that's called Rovio. So I've been there for 6 years. So I've been working in gaming and really high scalable applications before this. So let's talk a little bit about speed to market. As developers, we might come, the stakeholders, project managers, business owners, whatever, comes to you and say, we need to get this feature out. And you're like, oh, again. And yeah, they like to go fast. They like to beat the competition. They want to try, fail fast. You know, all these buzzwords that are around in the business jargon that we need to be the first ones. And then you are like, OK, how I build this the fastest way as possible? Because if I go the way I like, that is to build everything from scratch, I will take years. So then you start Googling around, and you find, oh, there is this thing called GraphQL. It promised me to go very fast. It has all these promises that you can do the backend and the front end separately. That sounds good. Then you continue Googling, OK, so what I can do for my backend? Oh, the serverless. That's very trendy. That's very buzzword. So maybe I should check these things out and see how fast I can go. I'm sorry to tell you, I will not give you the answer for that, but I will be talking about serverless and GraphQL a lot. So in this talk, I will start talking about serverless, a very, very brief introduction so we are all in the same page. And then I will move on to GraphQL. It will be a longer introduction because I noticed when I talk about GraphQL in technical conference and more in backend and DevOps conference, people don't have a clue of really what is GraphQL. So I will give you a little bit more explanation, and we will dig into that. And then we will dig into the love story of serverless and GraphQL. So that's the agenda for today. Let's start with serverless. I'm pretty sure you are all familiar with it, so it will be very fast. So serverless has few promises that they tell you when you check their marketing information. First, that it scales automatically. So you don't need to provision. You don't need to tell the serverless architecture or tools or platform frameworks or whatever you're using how much you need. You just use it, and it will scale up, and it will scale down. And you don't need to worry about it. And with that, it comes the pay-as-you-go feature. So you use a lot, you pay a lot. You don't use anything, you don't pay anything. And then it also comes the promise of no managing infrastructure. You don't need to own that thing. You don't need to update operating systems. You don't need to manage versions, firewalls, or things like that. You just use it. And you trust that the platform that you are building on top is scalable and reliable. And then one of my favorite features is the high availability. So for example, if you're using functions, you might have some problem in your function. Something went wrong. And then the function is returning an error. And then the next function that executes will work, because that previous function will go to trash, and it will start a new function. If you have a server, and the server is giving some random error because of some bad nature of your application, or even because something in the server was not working, you might get those requests that will return a broken response until you either kill that server or fix it. So I like that kind of high availability in the serverless offering. A lot of people think about serverless of functions, and that's OK. But it's only looking at a little tiny portion of the cake. There's a very big cake in serverless. So functions as a service is something like Lambda, if you're familiar with the AWS offering. But there are other products. And for me, my favorite ones are the backend as a server, backend as a service solutions. These are solutions that you can connect to your applications, and it complies to all the promises that we have from serverless, and you can build on top of them. So for example, if we look at one of the oldest serverless services, we have S3. Yes, S3 is serverless. So serverless has been out since the cloud, because S3 was the first cloud service that AWS launched. So just serverless is a marketing word that was launched with Lambda. But before that, we had serverless, and we've been working with serverless technologies for a long time. Here is just an example of some of the different services that there are in AWS. There is outside AWS as well many services, but these are some services that you might be familiar with and you have maybe used in your projects without even thinking that you were using serverless components. So you have in all the different parts of your application serverless concepts. So it's quite nice to realize that, yeah, it's not only functions. It's way more than that. Good. So that's my introduction on serverless. Now we are on the same page. We know serverless are not only functions. Let's talk about GraphQL. The first thing you want to know about GraphQL is that GraphQL isn't a specification. It's not a framework, it's not a database, it's not a server, it's a specification. It was done by Facebook many years ago, and then they open source it for everybody to implement it. So what that means that you need to implement it, yes. It's a specification, it's a piece of document. So when you implement GraphQL, it looks your architecture in a very simplified way, something like this. It's sitting between your client and your data sources. Yes, data sources, not servers, no services. In GraphQL jargon, all the things that are in there, they are data sources. And then when you have the implementation of GraphQL, you need to define a couple more things to make things magical. You need to define the schema. Schema is a very important, unique thing for your application. It's a place where all the types and attributes for each types are defined. It's a contract between your client and your GraphQL. So the client cannot just do whatever, and it will have this very clear definition of what kind of types it will get back from the data sources. It's kind of an auto-documentation thingy. And then also in that schema, you will have all the operations that the client can perform on the different data sources. So it's a really nice, neat of auto-documentation piece of text that we all love as developers. We hate writing documentation that needs to change at the same time with the code. This just documents itself. And the other piece of magic you need to write is your resolvers. The resolvers, for me, are the secret sauce of GraphQL. The resolvers would translate what the GraphQL server kind of gets from the client and translate it into something that our data sources know. If it's a SQL database, it will know how to open a SQL connection, have all the credentials, do SQL queries. If it's an HTTP service, it will do HTTP calls. If it's a NoSQL database, it will do all, for example, if you're using Mongo, all these Mongo connections and all the Mongo API calls. So it's a very specific thing for your applications. Schemas and resolvers, nobody can write for you. You need to write them for your application. Because of this, GraphQL has kind of interesting characteristics. I will list some of my favorite ones here. The first one is that the client can ask exactly for what they need. So you can have types that have multiple attributes, but the client might not need all those attributes. They just ask for exactly the attributes that they will display in the views. And in this way, there is no overfetching of information from the server to the client. There are smaller responses, and that's something we're all happy when you are building client applications. You don't want to bring a lot of data from the backend and then use one parameter. And the other feature that I love is that because GraphQL sits between all your data sources, then the client can make a request and get responses from many data sources in one network connection. So in that way, you're not underfetching. Sometimes for building client applications, you need to call 4 times your backend, one for the customer, one for the provider, one for the order, depending on how you build your application. And that's a lot of open connections that the client needs to do, and that's a lot of memory and battery and internet and things like that, that they are valuable resources for our client applications. So that's a nice one. Another one that I like a lot is that you can evolve your API without versioning. And this works very well. For example, in one of my GraphQL projects, we were building an app video. And we have created like 4 clients, iOS, Android, web, no, 3 clients. And then we have around 16 other clients that were smart TVs. Smart TVs are very kind of proprietary code, so we usually give them to companies that specify on building those apps. And they build the app, and we never asked them to refresh it because we forgot that the clients were working. And that was really good because we could evolve our API, and everything was backwards compatible. All the old clients were working. We didn't need to test 20 million versions in the past every time we launch a new feature. It was quite nice when you have so many clients that are not managed by you. So we talk about data sources. So GraphQL can connect to data sources, and what data sources can be? Anything. Anything that returns data. You're the one writing the resolver, so you're the one who needs to figure out how you get the data from there. So GraphQL is a specification. So let's talk a little bit about the query language. Everything is a type in the schema, everything. It's a strongly typed language. Every type has attributes, and those attributes are either like strings, booleans, integers, those that we all know. There can be an array of those, or then they can be other types, or then you can have an array of types. It's something like JSON. We are very familiar with that. And also inside the schema, you will have your operations, and those are also special types. The operations are like the entry door for your application. We have 3 different special operations, well, collection of operations. They're query, mutation, and subscriptions. Query is where you put all your operations that don't have any side effects. List, get, I don't know, search, whatever is your application is doing, that don't have side effects on the data sources. Mutations are operations that have side effects. Create, delete, update, you name it. And subscriptions are a special type of operations. So for example, I have a video application, like Netflix, and I want to notify all my clients when there is a new video coming or a new series. So I will create a subscription that says new series coming or something like that. And then my client application will come and subscribe to that operation. And when there is a new series, the server will send a message to the clients. And if you look at this, this is two-way communication. So when you implement GraphQL, you can implement it over HTTP and don't have the subscriptions at all, because that they cannot talk to your clients. Or then implement it over MQTT or WebSockets and have the bilateral communication. That's up to you. Again, it's a specification. So as I said, these are the entry points of your application. So you will have, your clients can only use these operations. Even though they are all the types and the attributes, they cannot mix and match in any way. They need to go through the operations that you provide. So it's kind of nice. You can restrict very well what the clients can do. And the clients can write simple queries like, I want all the videos, and say, OK, I want from the videos these 2 parameters, all the others I'm not interested, and then get that back. So it's pretty straightforward. I recommend you to check this web page if you want to know more. They have very big and complete language, so you should check it out. Good. So let's see how GraphQL works. Now we have all the basics. First thing, you write the schema, the magic sauce, the contract between your clients and your servers. You describe all the types and the operations. Then you write the resolvers to connect your backend GraphQL server to your data sources. You do this in the backend. And then the client makes a request. We've seen that. And then GraphQL uses the request resolver to translate from the client request into something the data source knows. So for example, the case of SQL, it will open the connection, and then it will do select video name, video ID from the table videos. And it will return a columnar thingy that we know from SQL data sources. And then that needs to be translated to JSON. So that's the resolver, the GraphQL resolver, taking care of that. And then GraphQL returns the JSON back to the client. So it's a very simple process that more or less the GraphQL is the same for everything. The magic is your schema and your resolvers. Now you might be wondering, this sounds very familiar. This sounds like REST. Well, no, it doesn't at all. It's not one or the other. You can use both. And they have totally different usages. And if you use REST and it works for you, it's totally good. GraphQL solves some problems that you might have in your projects. And I will show you at least 3 use cases when GraphQL has performed for me. You can mix them, combine them, do whatever, and maybe get some ideas. So one good use of GraphQL is to use it as a single entry point for your clients. You have a very big organization. Everybody is doing their microservices. Everybody is doing it in a different way. And then you have one client app, and the poor client developer needs to understand what all these people all around the world have decided and understand all the domain names that they have put, because sure, the customer in the customer service is the customer, is pretty clear, but the customer in the provider service might be a totally different person. So then your client developer is like, OK, how I do this thing? So if you have a team in the middle that is building this GraphQL, then maybe it's easier to have multiple clients, implementations, and they all talk to that GraphQL. It depends on how your company is organized, but this is the way we did it, and it worked for us because we have a lot of data sources and a lot of clients. So having one place where everything was organized really worked. And then if your backend changed, you need to change your GraphQL. that is way easier than ask all your clients to update. So that's another kind of benefit of using GraphQL. Another one that I like a lot, and it works quite well in my experience, is when you have an old service that nobody wants to touch with a stick, and then you need to add a new feature. And everybody's like, I don't want to do that feature, I don't want. And then you put GraphQL, and you implement that either inside GraphQL. For example, now you need to add authentication. Well, you can do that inside the resolvers of GraphQL. That's something natural. Or then you need to add a totally different feature, and you create a new data source, and GraphQL will be the single entry point for those two services. And you don't need to touch that old legacy service that is writing like 10 years ago by an engineer that left and was fired, and nobody, like, it works, but nobody knows how. It's a common use case. Another one is that you have a very complex API. Imagine that you're working in a company that has built a very big monolithic using SOAP. Why not? It's been very popular technology 10 years ago. And you're like in a factory or something like that, that software is not your main thing, but or your factory connects with that and works all your machines and computers, and everything is working fine. And then your business person comes, yes, I read that to improve productivity of our workers, we need to have an application in the Android device that has like, can show the states of the machine and things like that. And you're like, okay. So then you put GraphQL in the middle, and then you can give that GraphQL endpoint to some nice consulting company, trendy company that makes all these beautiful iOS apps, and they don't need to deal with the SOAP communication, they don't need to deal with whatever XML packages are coming back, or you don't even need to touch that very complex API monolith application. And then you mix and match, and you will find a lot of really good use cases for GraphQL. There's 3 ways to implement GraphQL in my head. The first one, go hardcore and say, I want to have GraphQL in Haskell. I will write it by my hand. I will put the resolvers. I will create the schema. I will put it in a server. I will scale it up, scale it down, maintain it, patch it, you know the way. The second one, likely the most popular one, is that you grab an existing GraphQL library, like Apollo. You put it in your server, you write your schema, you write your resolvers, you do a little bit of coding, not much. And then you put it in a server, you scale it up, and you scale it down. The new way, and the beautiful child that was born between serverless and GraphQL, is to use a GraphQL platform. Somebody realized that basically the GraphQL implementation is kind of generic. The only magic parts are the schema and the resolvers. The rest, it doesn't change that much. So why to ask every person who wants to use GraphQL to implement this, to maintain a server, to scale it, and to waste so much time in something that doesn't provide value for our customers, for our company? So these platforms are available, and there are many of them. And sure, the more you go down the stairs, the less flexible these things are. You cannot use Haskell to write your resolvers in the platform. They will be more wise and give you a couple of languages that are more popular. Or you cannot do crazy things because it's more restricted. But then, if you want to implement GraphQL, you want the basic features from GraphQL, in general, 80% of the cases. Then you always have the chance to do it yourself. There are some platforms. Apollo platform, that is the one from Apollo Library. So if you've been using Apollo Library, you have a platform. There is GraphCMS, GraphQL, and many, many others. You can Google for them. And the last one is the one I will be talking about, that is AppSync. So AppSync is a serverless GraphQL platform from AWS. And I want to show you one in particular because I want to show you some code. So I need to put you an example. So AppSync has all the features from any GraphQL specification. It goes tick every box because it's a GraphQL specification. It has real-time support, so you have the subscriptions, you have the bilateral communication. It has offline support, that's pretty neat. So if one of your customers or clients edit something in the app when they were offline, and then they put the phone online again, and there is conflicts between the data, then AppSync has a methodology to resolve conflicts automatically, or then you can write your logic to resolve the conflicts, because that's kind of nice. It will happen if you have a very complex application. It has support for many different data sources, and it has fine-grained access control. That's quite important when you're building client applications. Some of the ways that you can secure your application with API key. Don't recommend it for production. It's really good for testing. Just have an API key, and nobody that has that key cannot use it. If you're using AWS, you might be familiar with the Cognito User Pools. It's a service that you can manage databases of users and give privilege and basic management of users. It's really built in AppSync. Then you can use OpenID and AWS IAM. And then when you write your resolvers, you can say, well, this type of users, depending on what kind of security you have, but for example, if you have Cognito, you can say this type of user cannot access these types, or they cannot execute this operation, or if they execute this operation and get this type back, for example, in a profile, if it's not your profile, you cannot see really personal information, so you can define all those things in the resolvers. You don't need to build them in your data sources, because your database might not know who is querying. So you can put all those logic in the resolvers, and that's really powerful. It has support for many data sources. Some of them are native for AWS, and the connection is extremely, really deep inbuilt. For example, Dynamo, if you have a database in Dynamo, AppSync will create the schema for you automatically. The other way around, if you have a schema, it will create the tables for you. Lambda, the functions as service, you can invoke them super easy. I will show you how to do this. It's basically a second, and you have a Lambda. And if you have Lambda access, you can do whatever. Then you have Elasticsearch, Amazon Aurora, that is the SQL databases service from AWS, and then HTTP services. That with that and Lambda, you are able to do whatever you imagine. Resolvers in AppSync are written in Velocity template language. That is maybe not the most popular language in the world, but it's not that hard to learn. And it's a very powerful language. It lets you to loop and do conditionals and filters and all kind of things. And it's very connected to data sources, the native data sources from AWS. I will show you some examples in a second. So basically how it works, you create the schema, you create your resolvers and connect your data sources, and it works. Not much to do. Some customers that are using this, you can check them in the AppSync, how they are using AppSync, mostly for their client applications to provide information to different users they have. And they have nice use case. So now let's go to the AWS console. So this is how it looks. And we will create a new sample project that we will start from an existing project that we have there. This is really a great way to start if you don't know what you're doing, so you can see what the AWS experts recommend you. And this kind of event page will create a schema for you, will create the data sources, will create the resolvers, and we can navigate through this. It takes a little while to create everything, and then we can go to the schema. You can see there is the type comment with its different attributes. And then there is some other types that are kind of good practices from GraphQL. There is the events types. There is the mutations with the create event, delete event, all the other operations, queries, gets, lists, subscriptions. So you can see an example of a working application here. And then you can see the resolvers for the different operations there. And we will check now the data sources. Basically, there are two Dynamo tables. And they're empty because this is just created, so there is nothing in here. And we can run some queries against this and see how we can get some information in the table. So if we go to queries, it has this nice view that you can write your queries and test them against the real data sources you have. This can be in production, test, whatever, because the AppSync doesn't care. You can just name it production. It's good to go. And here, for example, we just created an event, and it appears in the database automatically, immediately. And then you can list the events that are there, and this is just going to your data sources. So this is very nice. But we don't want to do that. Clinky, click, 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 click around is nice to test and to play and to learn, but it's not the way we want to run our applications in production, because how we replicate that, how we make it maintainable, how we change things, how we have control. You know all these things. You are here for DevOps conference. So we want to do this as infrastructure as code. AppSync has support for CloudFormation, and that's amazing because you can build everything that we click in the past into code. I will be using a serverless framework to show you that when you deploy it, it builds to CloudFormation, but it's so much compact. that I can show you in a screen without driving you nuts. So I will use a AppSync plugin from Serverless Framework that makes everything super simple, and you will see how little lines of code we need to write an application. So we'll build something like this. We will build an AppSync endpoint that will have 2 data sources, one that is Lambda, one that is Dynamo. And these will have different resolvers to get to the data sources. Our GraphQL schema will have kind of one type, that is the task, and it will have 2 queries, that is hello world, very original, and get a task, and then it will have 1 mutation, that is to create a task. The get a task and the create a task are going to the Dynamo, and hello world is going to Lambda. So this is how Serverless Framework works. You have the Serverless YAML, where you define all your infrastructure. And I will show you how we will create this. So this is the beginning of the file. So this is a very simple project. It can be longer, but it has an AppSync thing there. So the first thing we do is just put a name to our project and then add the plugin. Because the plugin is what will make everything look nicer, because you could write this in CloudFormation, but why for? So that is highlighted there is the AppSync code, so it's very minimal. The first thing we are going to do is put a name and define what kind of security we want. In this case, it has an application key. But if you were using Cognito there, you need to define the user pool ID and a couple of more things that you know how to get if you are familiar with Cognito. So it's very straightforward, and you can use any method that you want for authentication. Then the schema, we don't change the name. It's the schema.graphql. If you want to change the name, you can. It's possible. And then we have the 2 data sources defined there. In this case, I will define the Lambda and the Dynamo table in the bottom of the file. So all the application infrastructure is in one file. If you have a bigger application, you can define this in different files, and you need to make a reference to those Amazon resource names in here when you define your data sources. So we have one Lambda and one Dynamo table called task. So it's very straightforward, very simple. We define the resource, and then we give a role for this to be able to execute commands on that. And then in the mapping templates, we have the resolvers, and we can check the schema. And there is the 3 operations, hello world, get task, and create task, the type task, and at the bottom you can see the entry point, the queries, and the mutations. There is no subscriptions in this example. So if you want to see the data source, the mapping, in this case, the resolver we call it, but in the AppSync word it's called mapping template in this thing. But it's the resolver. It goes, you need to specify the data source, then what kind of type it is, if it's a query, a mutation, or a subscription, and then what the field is the name of the operation, in this case, the hello world. And then you will have request and response, and that's the resolver for the request and the resolver for the response in Velocity template language. So if we go to the hello world, this is how you invoke a Lambda. Is how many lines of code? 8, from which there are so many brackets. So it's super simple. As you define the Lambda that is going to be invoked in the serverless YAML, then you just do invoke, and this thing knows which Lambda to invoke. And then you pass the arguments, and you say which operation in this case, because I will have one fat Lambda to do many operations. But you can have different Lambdas for one particular operation. So you can do it like this. So it's super simple. And the response is even more simple. It's one line of code. Whatever the Lambda returns, put it into JSON and return it back. Because this Velocity template language has a lot of util functionalities built in for your application. And then if we want to check the get task operation, here is the Velocity language template to get an item in Dynamo. We have specified the name of the table in the YAML. And here we do get item, and we pass the ID. If you need to do more complex operations, it's there. It's just one little file. And Dynamo has really good documentation on the AWS on how to do Velocity language template with Dynamo. So it's pretty straightforward. And those are the util libraries that you can use to get the argument from the GraphQL request into the task ID to pass it to Dynamo. So it has utils for many things. So it's pretty cool. And the response, again, give me the result from Dynamo and convert it to JSON. So it's very simple. So stop this. Now I deploy. If you're using serverless framework, just run SLS deploy, and it's up in the cloud in the time that it takes, a few minutes. And then we can see what happens. This is created. We have the schema, mutation, query, task, and that we have seen a few seconds ago. The resolvers in the side are there. And then we can see our data sources, the Dynamo table that is empty because we have not put anything there. And then we have the Lambda as well. And then we can run some queries. I will write a couple of queries for you to see how this works. And this is almost the end of the presentation. So you get a task, and you put a task ID. There is nothing in the table, so we are getting null. So usually every operation, you need to define what type is returned back. So you usually need to give some attribute that you're interested on that operation. So in this case, get a task returns a task. What is obvious? So you need to pass something, get something back. In this case, we are interested in the description. Then we want to add a new task. And for that, you need just to give a description. The ID of the task is generated automatically. Velocity language template has an util that you can generate like really good IDs for your Dynamos tables. So the partition keys are distributed evenly. That's very important. And that's another talk, how to create good Dynamo applications. But here we add a new task, and we get an ID back. And then I just can basically copy that ID into my get task, and waf. You get the tag pass. Let's move forward. So if you want to use this with a client, it's very easy. Give them Amplify. That is the client library for building cloud apps. It's in all the flavors, Android, iOS, React, Vue, Angular, whatever. And it's super simple to use. First thing you need to do is to configure it. Everything that was in the settings page for Amplify is basically what you need to give to your clients to start using it. The URL that Amplify is giving you to make all the requests, the security type, API key, Cognito user pools, whatever you imagine, you will need to put a little different configuration. And that's almost it, everything you need. And then the client, if they're using Amplify, they just can run query, mutation, or subscription operation on the Amplify library, pass the query, and it works. It's very fast. Best practices for using AppSync, and we run up. So important thing, if you're using Dynamo, don't do Dynamo scan. Dynamo scan is bad. Don't do it. Don't search in the Dynamo table. Do a good modeling of your data and try to create good access patterns. So it's very fast for Dynamo to return things. But if you go line by line searching, text searching inside your Dynamo, it will not be performant. And a lot of people do that because they don't know how to use Dynamo. So think on how to implement the search, because when you have clients, they all want search. So think about those access patterns and build them properly into Dynamo, or then use some other service like Elasticsearch for your search. Also be careful when doing HTTP calls because of latency. And it's not something bad, but just be mindful about it. When you have, maybe you have your server, your AWS region is Virginia, so you're in Kyiv. Your client will connect to Virginia. And then maybe that HTTP server that you're connecting is in, I don't know, in Ireland. So you're going from Virginia to AppSync, and then AppSync, oh, there is an HTTP I need to do. And then it goes to Ireland, and then it goes back to Virginia, and then go back to you in Kyiv. So your query is just all around the world. So there is a physical latency added there. So be mindful on your HTTP calls. Use as much as velocity language template as possible. Don't rely on Lambda, because a lot of people are, I can do everything with Lambda, so they do Lambda to use for Dynamo, for example. And Dynamo works really, really well when you are using it from velocity language template, so try to stay there, because again, you're adding extra latency that is not needed. So think about all the steps that are in the way. Use subscriptions properly, because when your clients are subscribed to those things, they will be receiving a lot of information in the background, and that will consume battery and internet consumption or whatever. And not everybody is in a free data plan, so be mindful on how your clients are going to use that, and paginate your large responses. Yes, give me all the products, and then GraphQL will give you all the products. That is like around 1 million of things. And your client might not be interested in getting 1 million records in the response. I don't think they can even handle it. So paginate them. That's it. Remember, there is a loft and you can ask all the questions you want to our experts. They will be there for you, so you can go and visit, and you can register in that link. I have a lot of practical examples and more about serverless in my YouTube channel, so you can go and check it out. I don't know if I have time for questions. Do we?
We. Let's check the more interesting on your mind questions you can answer on.
Somebody asked me, GraphQL for read-only? No, GraphQL has mutations and queries, so no, not read-only, but you can use it only for read-only. It's totally doable. Okay, somebody is responding to that. OK. There is a lot of questions that are very specific, so please ask me. And here is GraphQL is HTTP-based under the hood. No, well, it depends on how you implement it again. For example, AppSync is using MQTT, so it depends on how you do it. But yeah, and Postgres implementation with AppSync, use Amazon Aurora for that. And the other questions that are quite specific, come and ask me, or ask me in Twitter. I have DMs open, so I'm happy to answer what I can. So thank you.